Okay, Jai Hind everyone. I am Achintya Pandey as Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I am going to discuss about UML diagrams for effective modeling. Okay, so basically in my last video of object-oriented system design, I have simply discussed about the feature of object-oriented programming for the development of the software systems. Okay. So here we are going to discuss about UML diagrams basically. So UML is basically Unified Modeling Language, and that is used for the to visualize and document the UML is basically used for the visualizing a document model of software systems. Okay. So UML has, how you are going to model, okay, how you are going to visualize or document the software system processes, okay. So that consists into the UML, okay. So you can say that it is basically visualizing, specifying, constructing and documenting the things. Things means software systems, how you are going to model that, okay. So it is there are many open tools, okay, by which we could simply model the software system process, okay. So UML, that is Unified Modeling Language, it is a graphical language for visualize and document model of software system, including their structure and design in a way that meets all of these requirements. That is visualizing. Visualizing means simply a graphical model with precise semantics. Specifying means the model are precise, unambiguous and complete to capture all important analysis, design and implementation decisions. Okay. And next is constructing, means the requirement of constructing also mean because the models can be directly connected to programming language which allow forward and reverse engineering. Okay, forward and reverse engineering means we give code and we could draw the logic, okay, flowchart, and by even the logic we could capture the code. Documenting, diagrams capture all pieces of information collected by development team, allowing sharing and communicating the embedded knowledge. So basically how a program you are going to model, not a program, a complete system. It's not application, software systems. Okay. So you are going to model that. So that modeling, all the things like their structural, their behavioral, their architecture and everything. So they comes under these kind of diagram. Everything is included under these 9 diagram. Even you could add some more information if somehow it gets missed by creating your customized things. Okay. So UML diagram are it is a diagram is the graphical representation of a set of elements, most often rendered as a connected graph of vertices and arcs. You draw diagram to visualize a system from different perspective so that you could do analysis, okay, and by analysis we take decisions and all that, okay. So in practice a small number of common combination arises which are consistent with the 5 most useful view that comprise the architecture of a software intensive system. For this reason the UML will include 9 such diagram. Means out of these 9 diagram we could consider we would have everything, okay, which require in the modeling process. So we will see first how these diagram could be draw, okay. How this could be represented in UML, okay. So there are a standard way to represent these class diagram, object diagram or up to the deployment diagram. So that we will see. Okay, like in class, we have said that class is a collection of similar type of objects. Okay, so how we are going to represent a class? So class is simply class or even object. They both simply represented by the rectangle. Class simply contain what? Class contains simply the variable and the functions. Okay, means data and function. So the class diagram is basically represented by the rectangle. Here you can see. And this rectangle, this is the class diagram. This is a class diagram. Like here, there is a given, order system. Like in a restaurant, we order something. So suppose we are going to visualize or model order system. Okay, customer order system of application like restaurant order management. So how you are going to draw, how you are going to model all those things. So let's see in class diagram. So first we would have to identify how many different class would have. Like we in particular in order management system application, we could have a customer, we could have order, even the order could be categorized into whether it is a special order or normal order. So there is a way of generalization or sometimes called specialization. Okay, and this comes under the extended ER features. Okay, so here we can say that simple class diagram is represented by the rectangle where there are three sections. One section has the name of the class. This is the name of the class. This is the member variable or it is the data of that class, and this is the function. So even you simply write customer, there is no need to write data and all, but in a standard way, class diagram contain name of the class, name of the data and name of the function. So there are three sections in a particular class diagram or standard class diagram. Okay, so these all are different class, like customer is a class, order is a class, special order and normal order. This triangle component show the like suppose a feature could further divided. Okay, like the feature of generalization or specialization, like order is further divided in special order. Even in special order, if say if you further categorize, then you could do it by a triangle component, and it is called a ISA component. Is a component, order is a special or normal. So that could be depicted by the triangle. So we could classify into this. Okay, so by triangle component we further classified. Okay, simple. So this is the class diagram. So the following diagram is example of order system of application. It describes the particular aspect of the entire application. So first of all, order and customer are identified as two elements of the system. They have one to many relationship. Say a class or object, another object. So the association between objects are kind of, it could have one to one, one to many, many to one, many to many. So that could be represented by following these numbers 1 and n, means one to many. A customer could have so many order. Okay, like so this is one to n communication that could be shown on the line. Okay, next is object diagram. Object diagram are similar just like a class diagram, but the difference is simply we also show the instance. Okay, like object. So simply this is the name of the class and this is the name of the object. So we followed by the colon. Okay, so object and class diagram both are similar things. Next one is component diagrams. Component diagrams basically they are used during the implementation, means coding and all. Okay, so component diagram are used during the implementation phase of application. It is prepared well in advance to visualize the implementation details. Okay, so the component diagram required to be additionally prepared. Okay, so before drawing a component diagram, these artifacts are identified clearly. what are the file used in the system, how many types of files, how many library routines, and all the artifact relevant to that applications we must identify before making the component diagram. And what are the relation among the artifacts. Okay, like in simple order management system, we would have type of these all are the customer order, normal order, special order. So we are simply using the Java coding just for that. So a type of file is Java file. Okay, even the library, if they are I mean different set of library are going to use, then we would have to identify into the component diagram. Means all the components related to the implementations. Okay, so component diagram can be used to model the component of a system, to model the database schema. Database schema means design of the database. Okay, what are the name of the relation, type of, how many relations, what are the attributes, constraint, and all that even. So this component diagram can be used to model the executable of an application. This component diagram could model the system source code. Okay, means code basically. Okay, this is the deployment diagram. Deployment diagram means you are going to deploy the code into the onto the internet. Okay, so what are the various node? Okay, at every level, like if you want to deploy some, say, kind of this application order management system, so we would have a user, would have I mean desktop or mobile. Okay, it could require modem, we would have type of servers, okay, internet and all. So these all are I mean kind of different nodes. Okay, so how you are different nodes, how you are going to exhibit, they comes under the deployment diagram. Just so here for example, for order management system, we would have these kind of different node, like so many servers, modem, system, user, internet, and all that. Okay, so component diagram and deployment diagram are closely related. They are used to describe the component and deployment diagram, so how they are deployed in a hardware. Okay, okay, so what are different nodes involved in that comes under the deployment diagram. Use case diagram they are considered, use case diagram are considered for high level requirement analysis of a system. When the requirement of a system are analyzed, the functionality are captured in use cases. Okay, so use cases are the system functionality written in an organized manner. Okay, the second thing which is relevant to the use cases are the actors. Actors can be identified as something that interacts with the system. Like here in order management system, customer is an actor. Okay, so customer basically orders. So this order could be special order or normal order. So they are basically the use cases and customer are the actors. Okay, so actor can be human user, some internal applications, or maybe some external applications. So when we planning to draw a use case diagram, we should have the following items identify. Means what are the functionality to be represented as a use case, what are the actors, and what are the relationship among the use cases and actors. Okay, interaction diagram. Interaction diagram means this is a sequence or collaboration diagram. Means like in flow chart we see the stepwise solution. What are the first step, the next, then next, and up to the end. So this comes under the here interaction diagram. Okay, so so the above diagram shows the message sequence for the special order object, and same can be used in case of normal order object. Okay, like here sequence diagram, we would have customer, order, special order, normal order, and this is the time reference. Okay, like customer initially customer send message. Okay, that means send order kind of mechanism or functionality will be invoked. Okay, so customer send order, this will be the first I mean activity. Okay, then the order get confirmed. Okay, okay, if it is okay, then it will dispatch and all. So we could be represented in time reference. Okay. So this come under the interaction diagram. This is of two types, either sequence diagram or collaboration diagram. Okay. So in sequence diagram, in collaboration diagram, we simply number like 1, 2, 3, 4. In sequence diagram, it is not needed that's to mention the sequence like A, B, C, D, E, R, 1, 2, 3, 4. Okay. But if we explicitly mention like this is the first, then second, then third, okay, we somehow keep the numbering system, then this comes under the collaboration diagram. Okay. So we would have initialization, then customer order, special order, end of the process. So like this is the 1, 2, 3, and 4. So in the collaboration diagram, the method called sequence is indicated like 1, 2, 3, 4 by some numbering technique, and in sequence diagram it is not mandatory. Okay. Next one is state chart diagram, means there could be various state like idle, send order request, select normal or special, or whether order gets confirmed and all not, whether order is dispatched. So this comes and like this. So this comes under the state chart diagram. So the state chart diagram are very important for describing the various states. States can be identified as the condition of objects. Okay, like suppose customer order, whether the condition is whether it is special order or normal order. If there is a special order, whether customer has confirmed or not. Okay, so this comes under the various states. Okay, so condition of when a particular event occur. So before drawing a state chart diagram, we should classify the following point: identify the important object to be analyzed, identify the states, identify the events. Next one is the activity diagram. So activity diagram, before drawing activity diagram, we should have the following element like activity, association, condition, and constraints. Okay. So the mechanism, okay, like in the order management system, we could have activity like customer send an order request. Second activity, order request, system confirm the receipt of the order or not. Condition check, okay, whether it is a normal order or special order and all. So this kind of oval and rhombus comes together, okay, and this could made as a activity diagram. Okay. So basically UML diagram are, we can say, these 9 diagram which include like class, object, and collaboration, sequence, activity, state chart diagram, by which we could model any application or even the system. So just by visualizing the things or just modeling, we would have better decisions, we would have better analysis, and the decision could be taken on behalf of that. Okay. So this is what about this UML diagrams. Okay. Thank you very much. Thank you.